Hi everyone. If you just logged in, I just want to welcome you to our reverse engineering webinar on the topic, how do you efficiently convert scan data to manufacturing ready CAD? My name is Pauline. I'm from GoMeasure 3D, and I just want to take a time to thank you for joining us today. It looks like we're right on time, so we'll just get started. This webinar is being recorded. We will send you the recording after the session next week, so you can rewatch it at any time. And if you have any colleagues who would be interested in this topic but weren't able to join us today, we welcome you to share the email with the recording as well. We're going to keep this webinar pretty casual, so please feel free to ask us any questions at any time during the session. I'm excited to introduce our presenters, Paul and Costa. They were just recently at Rapid TCT, which is a 3D printing and additive manufacturing trade show in Boston. We've been a reseller of QuickSurface for 8 years, and both our presenters have seen a lot of customers run through these challenges where they're trying to convert scan data into usable CAD, which is why they wanted to talk about this topic today. Paul is our resident reverse engineering specialist, and he is responsible for operations here at GoMeasure 3D. GoMeasure 3D is a supplier of Artec and Zeiss 3D scanners. Paul helps teams streamline workflows by combining scan data with reverse engineering solutions like QuickSurface, as well as inspection software for quality control applications. Also joining us today is our special guest, Costa, who is the founder and inventor of QuickSurface. He's very well known for taking a hands-on approach to helping teams solve everyday scan to CAD challenges. He shares a large, extensive library of tutorial videos on YouTube, which he um, demos how to solve these challenges, and he regularly hosts workshops and webinars, which you can find on the QuickSurface website. So today, Paul and Costa will be sharing their knowledge, expertise, and best practices in Scan to CAD, and Costa will be demonstrating the Scan to CAD workflow using QuickSurface. And with that, I will hand it over to Paul.
So to get started today, let me just kind of establish a baseline of some scan to CAD myths. So the two primary myths we're going to talk about is one, when you purchase a 3D scanner, that scan data can just be used as a CAD model, when in reality, 3D scan data is polygonal mesh data. So either like an STL, an OBJ, PLY, things of that nature. And it's not something that you can just very easily edit as a CAD model. The second big myth is that there's a one button solution for converting scan data to CAD data. Now, this isn't necessarily a myth because you can do what's called auto surfacing, as you can see here in this example. However, auto surfacing really doesn't work for 90% of customer applications because while we are converting that mesh data over to a CAD NURB surface, that NURB surface isn't really easily editable. So, in my personal opinion, there's four different reverse engineering workflows that most customers will use. The first one is auto surfacing because it does work for some customers. The second one is going to be more of your prismatic modeling. Third, you're going to have your freeform modeling. And then last, you've got hybrid modeling, which is a really interesting topic. If we get time today, I'd love to cover it. But that's really blending your auto surfacing with prismatic modeling. So today we're going to have Costa here to help us kind of walk through the basics of scan to CAD workflow. So you can see here, this is a sample part that we'll be getting to later in this presentation where we can take that scan data and convert it over into our CAD model. So with QuickSurface, our primary workflow is you're going to take a 3D scanner. We're going to turn that scan data, that STL, that OBJ or PLY type file, put it into QuickSurface. And then from there, we can take it over to one of your standard CAD CAM softwares, or we can simply just 3D print or machine that CAD model. So with that, I'm going to go ahead and pass it over to Costa, and we're going to keep this really casual. So if you see something interesting or you have a question, feel free to put it into the Q&A, and I'll be monitoring that to try to answer questions as we go along. So with that, I'll go ahead and pass it over to you, Costa.
Thanks, Paul, for the great introduction about reverse engineering. It's very interesting because we face this every day, me and you trying to help people understanding all different approaches, the myths, the expectations, and
Exactly.
so on. So before I begin in technical details, I would like to show you what is actually Quick Surface in reality. Quick Surface is developed by our company as a standalone application, and it serves one goal which you presented in your presentation. And it's mainly focused to be able to import a scan data from any 3D scanner which can generate a mesh, as you can see this example on the screen. And with the tools which I'm going to explore today, being able to generate a CAD model that this can be exported for manufacturing, for assemblies, for 3D printing, and so on. This is the gap we're trying to fill, as we know that the 3D scanning evolved a lot during the years, but there is still this missing step how to actually get this mesh and be able to use it in your CAD package. There are so many different applications where you can use this. One of them is, as you see, in the automotive, which currently this model is what we call the hybrid type of modeling. I'd like to load a couple of examples so you can see how broad these applications can be. This is I chose on purpose a really bad scan. I apologize for this, but this has been on purpose because the reality is that the 3D scanning may not capture the real world really well, but this doesn't stop you to create your perfect design intent, as you can see on the screen here, and be able to put it into the manufacturing. Together with this, we can just work on more complex shapes, typical for the automotive industry, like the one you see on the screen. Again, you can import the scan data, and then you can just convert it into a solid model that you can export. Furthermore, with this, it's not really limited. Our abilities go way beyond this. There are applications where the people want to just bring in an existing digital twin of the scan of a physical part, and then they need to build something around it that, in this example, it needs to support this. And once you have this, you can just export, print, 3D print it, and recreate in the best possible way. Also, just to show you, we are not limited to purely mechanical engineering parts, but there are a lot of challenges like the one on the screen where you have something really complex. I see this a lot as a request on our forums and groups. How can actually replace this type of shapes and be able to create a really complex freeform shapes? And this is where we really are strong. Also, another
Right.
industries is something like the fashion that people can use it for the shoe modeling. You start with this type of absolutely free form, which has nothing to do with the lofting and extrusion and stuff. It's just made by the human. And how you actually can put this into production just by using our tools. Further, also, what as an application, this is one of my favorite part is that scanning to print is one type of workflow, but in many cases it may fail because you can scan the part which is already broken and you can just recreate and join these meshes. And if you send it to the printer, this will print what you see on the screen. So this is where, again, the reverse engineering takes part to be able to reconstruct this into your perfect model. And not only this, if you can see here, it's a really good example that you can enforce, modify your models, apply different properties to it, so it can be much stronger. It can replace the existing, not the great created part, and be able to do this. So I hope you got the basic idea of the power what Quick Surface can do, but how it works and what is the process of creating this, and this is what I'm going to show you today. As you can see, this is the main screen of Quick Surface. We have a lot of tutorials that you can enjoy just starting step by step, and you can go through this, but I always recommend that you start with the basics. we'll go and show you how you can actually reconstruct a very basic part like the one on the screen, and what are the fundamental steps during the reverse engineering. It always starts with the simple part. So the first very important thing that we see with the 3D scanning is what we call alignment. Alignment is positioning the mathematically positioning the object into a correct coordinate system. Coordinate system is something that you can see, on the screen that defines X, Y, Z. This would mean that if I place this in the standard views, the object should be nicely placed, and not only nicely, but accurate. If you're talking about the manufacturing, then everything needs to be perfect. QuickSurface allows you to go through these steps from the left to right by importing the scan data, and then just following the simple steps. At the end, you'll be able to recreate your CAD model. So as I said, one fundamental thing at the beginning is how can we align this? What it means alignment. This means, in my case, that probably this base plane is my XY plane. The origin is somewhere here. This is the other plane, YZ, and the third plane. But how QuickSurface can help you with this? So I always start with something which is called extract primitives. Extract primitives allows you to just pick a portion of your scan and tell the software to identify it as a plane, a cylinder, and one of these standard primitives that will allow you to actually be used in an accurate way to create your alignment. And let's see how this works. I'll just turn off this for now, the coordinate system display. By default, when you start this extract primitives mode, it has a number of selection tools. What the selection tools means, they simply will paint in a different way the triangles on the mesh. In this case, I'm using what is called the magic one, that it's a curvature-based algorithm that if you just move it, you can see it just takes the angle between and just selects the area. If the data are noisy, they're ignored. And this is your definition of what a plane should be like. Then in this case, I can just tell the software, okay, I know that this is a plane, let's create a plane. What we have here is what is called analysis. Our background comes from metrology. The metrology and the 3D scanners really overlap, and they're really important. And I'm going to explain what this means. Analysis, the scan data are always noisy. When you scan, they're not perfect. There's some variation in the shape. So all these points, they never lie on the perfect plane. And analysis allows you to keep control over the process when you define your primitives, your geometries to recreate the CAD model. What you see on the screen is I'm working in this case with a 30 microns accuracy. I have control over this. For example, I can say I just want to be at the 10 microns, and then you can see different pictures. You have a colored visualization of what this means. So the green means that everything is within 10 microns tolerance at the distance to these planes, and everything else is away. And then it can give you a good understanding what's going on. As I'm happy with this, I will create my first plane, and this remains as a geometry. If you remember, I was talking about alignment. In this case, when I need the alignment, I probably want this plane to be on the side and then be able to recreate this. You can see now I see some machining problem here. This is not the problem of the scanner. It's simply the part may be deformed, or maybe during the process of manufacturing, something has happened here. But this is the design intent. You need to decide what you want to do. A lot of more advanced users here are asking me, so what about if I want this plane to be fully perpendicular to the other one? When you advance, you will be able to understand, but we also support these tools. For example, I can say auto constrain, and you can see based on the AI algorithms, it's automatically determines and decides that this needs to be perpendicular. So this might be really important for your needs. So once I'm happy with this, I can just create. So, but on top of this, what we have also, if you explore our tutorials, what it's called the segmentation tools. How the segmentation tools works is similar to this magic wand. it does the job for you. It just extracts these areas of interesting shapes that you can then see visually on the screen and decide to take your actions. For example, here I can just pick this one and say this is my plane. If you remember, we are working now with this auto constraint. I can just switch this on and off. What is interesting that is you can see if I just turn this off, the algorithm finds the best plane, but it doesn't need not necessarily be perpendicular to anything else. But if I put these constraints, the algorithm smartly analyzes and creates this perpendicular to my plane too, but at the same time tries to fit it in the best possible way, and you can see this result. So what we doing QuickSurface is offering the tools so that you can process, but then it's in your hands to take the decisions what the next step should be. So I'm really ready with these three planes. Let's do and align our object. We have this what it's called alignment, and it's aligned by coordinate system. How it works is I just pick this plane and it tells me that this will be my XY plane. In this case, I need to flip it. We have a visual feedback to what's going on, and then I can just pick this one. The second one will define where my x-axis will be, something like this, and then pick this one, and now you see that it's fully defined. I can just apply this. This means now that my object is fully defined. So I hope this helped you to understand the fundamental first step. Whatever shape you start with, you always start with the alignment. But let's move on and start creating this shape. Because QuickSurface is very close to a CAD modeling package, we support everything that you are familiar with, like extrusion, revolve surfaces, and so on. In this case, I'm going to create my 2D sketch. The difference here from any CAD package is that our 2D sketch just interactively allows you to move this plane, and it actually captures the data from the actual scan. As you can see, I can just move and pick the best profile that I like to. I can just press create. What we have here is still not a real sketch. We have just points from our noisy scan data. If you zoom in, you can see that they're not really lines. They're just points from the scans. But then we need to start recreating in a traditional way the sketches. You can do eyeballing just by creating a rectangle. It's like in any CAD package, I can just draw something like this. Or we can use our technology to automatically extract the features as you from the scan data. We allow manual feature set like, okay, I'm going to just brush and say, okay, this is my line, this is my line, this is my line. So I created these 4 lines. If you have much more complex shape, this is really important. The software automatically will determine the best fit. And then I can just go back and say, okay, now you intersect, and it will create my first sketch. Let's try to extrude this, and I can see that this is my extrusion like in any CAD package. What is the difference here? Because QuickSurface is dedicated to reverse engineering, we provide a lot of tools so that you have a full control. I have no idea as a user where this should be. Should I just drag it and put it somewhere here? You know, eyeballing, it's not for manufacturing. You need precision, you need accuracy. If you remember, we introduced this analyzer tool, so which works in most of our tool set. So in this case, I can just enable it and start dragging and just move it and see how it fits. So I can get a decision what to do. But furthermore, what we have here in our extrusion is what it's called snapping. This will mean that if I just pick a point, it will just recreate the shape through these points from the scan data, as you can see on the screen. Let's loosen a little bit the tolerances, something like this. So let's see what's going on here. Let's try to play with the bottom. It's snapped and it's nice and green. Everything is within 30 microns. But what we see on the screen, it's a bit weird. You know, why it's not the same, why it's not green. And this is the problem of the real world. Not every part that you create is already wrong. You know, this part is nothing wrong with the scanner. It's just simply the part has been deformed. It's the plane here. It's not what you want to do. But this is, we start speaking about the design intent. Do we actually need this to be perfect and compromise with the difference between the scan data? Or we want this to be ideally to the scan data? If you want to make it the design as it is, we can also do this, but also in this case, it allows you to create what it intend to be. This is what we understand in our industry as a design intent. But let's move on and create our next step, which is, this extrusion on top. If you remember, I can just.
And Costa, while you're doing this, a question came up regarding whether or not we can do a silhouette of the part. So, do you mind briefly showing the outline mesh tool
Yep,
set? Yep.
I'll show you. Let me finish this part and I'll just bring in a little bit more complex shape where this is really obvious to
Sure.
do this.
Perfect.
Yeah, I keep this in mind. I'll jump into to this. So let's create this shape here, which is the circle. I will create it. If you remember, we have this as a reference, just as a scan data. We can use our sketch assistant, which is actually automatically can detect the shapes. In this case, it just figured out that this is probably around 20 millimeters. You have some options here, how accurate this should be, and so on. That this is 1994. I can just accept. But now, going back to the CAD industry and design intent, we have the same like in any CAD package. I can just put the dimensions. In some packages, it's called smart dimensions or just dimensions. What you see on the screen is that the software determined that this radius should be 19.9994, which is for the machinist, this is a nightmare. You don't want this to be this dimension. So you have the full control to just put it the correct value and then work in the correct way. So I can just extrude this. And if you remember, I can just drag this and it will just stop and snap to my body. Hey, let's see what's going on the top. I can just pick this because the snapping is on and I can recreate. Like in any CAD package, I can just go and combine the two solids and press OK. We created our first solid here, but let's finish our job and see what's going on top. We have a chamfer here. What we can do is just pick again and start doing the chamfer. I'm sorry, I was probably too quick. I can just pick this body and say I want to make a fillet. Now we need to pick the edge, and instead of fillet, I'm just going to create a chamfer. So here is the difference between us and any traditional CAD package. In your CAD package, you probably know what the chamfer is. What is the size of the chamfer? I have no idea here. So I just do this visually. And that's the difference here. What we offer is this reverse feedback. So if you have the analysis, I can just start dragging and see my reference underneath where it becomes green in real time. This is really proprietary of our software, which is really true real time. And I can see this number, it's 58. Now I can take a decision whether it should be 0.6 or 0.5. This is very easy to take a decision. Even if you see this yellow area, probably this is the best way for you to manufacture this. So this is really how important this is for this process. So I hope you got this basic idea of the very basic part. I will switch now to this silhouette you're talking about. QUICKSURFACE, if you download the trial version, even if you are a commercial user, I highly recommend that when you start, you use our built-in help example files. If you just go to help, examples, we provide, this type of help files here that are available for you to start. You don't need to jump in and start with your own parts immediately. Just go through these parts because they are well described in the tutorials. You can learn from them. And this is for you to get confidence. So let's see this part. If it is pre-aligned, it's nicely aligned. And I'm going to do a 2D sketch. let's try to create on this side. Whatever I do, I cannot just capture the profile of the shape in the best possible way, in the correct way. As you can see, whatever I do. For this reason, we provide numerous additional options here, which is called stacked sections. If you get more advanced, you can see this, how to use this stacked section. But to answer to your question, it's something which is called outline mesh. How it works, it just takes the mesh, as you can see on the screen, and using algorithms like in any CAD packages, it just outlines the shape. As you probably see here, we compromise with the quality of the scan, but it's a true outlining. So this is how the outlining works. And again, if you remember, I told you that the 2D cross-section initial creation is not it's not the final sketch, but it's just um, scan points that you use as a reference. In this case, Sketch Assist is not working. It just requires a single sketch. But what we can use the fit primitives options. And if you remember, this is what we've been doing. I can just brush over, create this here. I just recreate very quickly my lines. Me and Paul have had a lot of conversation of this about the usability. What I normally would do is just start with the lines and then stay focused on the fillet. Let's go press back because I created my major shapes. Probably I can just fit a circle, but not. I'll leave it for later. I'll just go back. So what you can do here is our smart algorithm just to automatically intersect this. But we don't have these fillets here. If you remember, I was telling you about the smart detection, what is this radius? What we have here, if you press Control and just brush over a corner, it automatically will determine the scan data underneath and suggest for you a radius that it can be used in this case. Again, this is a fillet, but the part is completely damaged or changed, so it's really in your hands what to do. Let's try to do the other fillets. If you remember, Control, just brush on the corner. It's as easy as just a toy. I can just brush over and recreate. And once I'm ready, I can just press Extrude. I'll turn off the snapping and analysis for now. I can just, actually, why not snapping? Let's put it on. I can just put it here. You can see the shape. I can just put it and place it somewhere here and recreate. There is another question from Paul, which reminded me, is that, Costa, what about parametric modeling?
Right.
QuickSurface is a pure parametric modeler. What this means is you have the history tree, and like, Fusion has it a little bit different. It calls a history line. SolidWorks traditional has this feature tree. It's very similar to this. What this means, I can just go back to Sketch and say, okay, I just need to recreate this hole here. I take a decision what to do. Go to Extract Primitives, fit circle, and just brush over onto my reference point. It just created the circle for me. As I told you, you have control to change the radius if needed. I can just brush over and recreate this, and then I go back and press OK. As you can see, this is just a normal parametric modeler that you can just recreate this shape.
Yeah,
So,
and just to,
yeah,
if you don't mind me jumping in there for a second, Costa, the parametric side of this and kind of some of the topics you've been discussing here from the analysis and the parametric aspects of QuickSurface are extremely useful for maybe not the beginner for reverse engineering, but once you get a couple steps in, the biggest challenge that I always see is discovering design intent on a part, right? Because more often than not, these parts are something that's like historically manufactured, right? Something that somebody designed well before you, which is why you're trying to redesign this part. And in that process of discovery of what that design intent's supposed to be, you have to make a ton of changes, right? So being able to have this parametric capability or being able to analyze the parts up front and put your constraints in can really speed up the process. 5 or 10 years ago, we would just have to rebuild a part, and you may rebuild a part 5 or 6 times before you get it right, right? Whereas now we can just adjust it on the fly. So,
That's the one of the big advantages, that you can actually keep control over the whole process. I didn't introduce you, but at any point during your modeling, you can just press compare
yep.
and just decide what's going on. Basically, on this, this type of approach, as we have been discussing so far, this is a typical example that you can just create cutting, extrusion, and revolve, and you can see you can reconstruct this part in the best possible way. Now, here it comes again. Okay, guys, you showed me all these bolts and nuts and prismatic shapes, but we have a way more complex shapes. What should we do when we have a car parts, plastic molding and stuff, and so on? So this is where we would like to speak a little bit more about a free-form modeling. This is how should I start? Probably with this one. So this part also comes with your help example files. Paul showed this on the presentation.
Mhm.
It doesn't fit to the traditional way. There is no extrusion, no revolving and stuff. So what should we do? QuickSurface allows the users to use what is called a freeform modeling. Freeform modeling is based on a technology which is known in the industry like a sub-D. How this works is you create just a small rectangular patch, as you can see on the screen. You can think about this as a simple surface. And what we offer is that you can just start, if you go in the tutorials, really I don't want to go too much in details, just to show you in principle how it works. You can just very quickly wrap around the shape, which is very complex and that otherwise you cannot reconstruct. You can just move around. And you can see that within a couple of seconds, I just recreated this, just double click here, move it around, shape it here, build it. And you see how easy I can just recreate this shape in the best possible way. But what is unique about QuickSurface about this? The ability to have the best possible way to reconstruct this. And what I mean with this, I created this. Probably you can create this in other packages, but first question is how close it is to the reality. What did I do? How, so what we have here, I can just turn on and I can show in real time how close I am. Let me put it 50 degrees, how close I am with the underlying data. Another technology which is unique for QuickSurface is what is called the snap to mesh. This means that I can just pick this shape and just move it whatever in the way I want, and I can just drop it and it will automatically snap to the mesh. In this way, I have the full flexibility to control to create what I want. Here I can see the deviation is quite away from what I want to achieve. And then we have tools. I can just press increase the resolution, and then I can see what's going on and build this up and so on. And I can recreate my shape. If I just press, excuse me, this is just a normal surface that you can just go and use the thicken command, like in any CAD package. I can just say, I want this to be thickened. I can just probably make it in the other way, and I can recreate it. And because it's parametric, what I mean is that I can just go always come and improve my shape and just recreate this. And then when I'm done, I can just press OK, and this will be recreated. How good it can be, you can just imagine. This is not a traditional lofting and sketching and stuff. You can just drag and drop and you can recreate. And this is the fundamental behind our hybrid type of modeling. The other thing, I hope you understood what I mean, is the magic button. What I mean by this magic button is the dream of everyone. Just what about if I just want to do this without any user interaction? We have this already, which is called automatic freeform. And what it does, it just will analyze the whole scan data, and it will wrap around a multiple these small surfaces that will define this shape. Just with the press of a button, you just select how many of these surfaces you need. Probably you can put it low to 1000. Feature details, I would say it's kind of balanced. There are not so many feature details. I can just go preview and that's all. And this is not going to the cloud. It's not using any power machine. This is on my local machine. And you can see how smartly it just generated the shape that it needs to be created. You can see the deviation here. It's still within 50 microns, and I can press OK. So within just the press of a button, we created a solid that you can just export and use it. Now, what is the best thing about QuickSurface? I can just go and edit this shape. I can just open it and change my shape. If I need to do some actions, I can just improve here. I can just recreate and so on. And then I can just press OK, and this is will be reviewed as a normal solid or a surface. Now, the thing about automatic freeform is to be clever about what you want to achieve. And I'm going to bring my another part, which is part of the demonstration, and it's this one. What should we do in this case? This is, I spoke with Paul, this is handmade, but it has a purpose. Let's try to do our automatic surfacing. I'll just press go and see what the software will do. It will take, I'm not doing any magic. This is not pre-recorded. This is what the software does. And it just recreated what you see on the screen. No user interaction and no any special skills are required. And I got the result. And here is actually the big thing about the hybrid modeling. We recreated really nicely what it's something made by a human. If I just press compare, and then you can see the deviation, it's extremely well, but it's the problem of what you want to do. What I mean is that in this case, the whole approach of this algorithm is it just wraps around the small surfaces. This would mean that if I just go and edit, let me just turn off the comparison, you see that we don't have geometries. By geometries, I mean this is not a cylinder, and there is no chamfer or fillet here, so we don't have these properties. Although we managed to wrap around this shape, this is really not sufficient for the real manufacturing. Some people use QuickSurface to do this, but I would say that when you create this to a solid and export your CAD package, you will face again with the same problems. What should I do in these openings and the holes and stuff and so on. So there is a better way of recreating this. I'm loading the part that I recreated for this demonstration, which is very similar to what you just saw. The difference is that we've been using our hybrid approach to be able to recreate this. Because we are limited in time, and if we cannot go too much in details, I'll try, we have some minutes, I'll try to show you the approach, but you need to use this auto freeform in a way that it actually complement your needs. So your extracted geometries, which are really critical for your processes. In this case, I believe, these planes is what I need. I want this, holes to be exactly as the geometries as I need. But because it's a casted part, I can just leave everything else to be recreated in a quick way, so I can save time for the production and so on. Generally speaking, how it works, I will try to reproduce the idea. We go, if you remember, we have the features which is called extract primitives. This is automatically goes to segmentations mode. I can just create this plane. Let's not constrain it. Then here I will just play with the slider to be able to pick the cone on the cylinders. In this case, I know it's a cone. I played with this because if it's a cylinder, It just gives the deviation. You see how powerful it is, the inspection. You can immediately identify what actually the result should be. I can just create this. And in this case, I will create this 4 columns here that I needed. We'll create and stay. We'll also recreate. So I have these 4 geometries. What I can do is just select everything and say, I want to trim. How do we trim? It's very simple. You just pick and remove what it's not needed. You remove the excess surfaces, and you can see it tells me it's a single surface, and I can press OK. As you can see, I created what it's needed for my main shape. I can just go then and edit the scan. I'll just duplicate the mesh so I can keep the original. And let me show you what we can do. I can just edit the scan. And what we have here is the ability to actually use this shape and tell the software, just get rid of all the meshes which are near the geometries within 0.5 millimeters. It's a little bit more advanced, but what happened here is that I recreated the shape, which is remaining as a freeform, that it's not geometries. It's not so interested for me. And then I can just use this the way I need later, just by using the automatic freeform. Let's go to automatic freeform. And now this is the things that I need to recreate. So once I recreate this, I'll be able to just edit and just be able to edit this. Then I can just go and we have the ability to turn off this snapping, and then I can just tell the software, okay, you just need to be a little bit bigger. And then I can just trim with my other geometries, and in the end, I'll be able to achieve the final results that I showed you earlier. So I hope that this somehow gave you a basic idea of the power, how you can just combine the technologies which are not available in a traditional CAD packages to be able to resolve problems that are for the manufacturing. And because we have done some scheduling on the webinar, I would like to stop for now and open the hand over back to Paul for the Q&A session. We are still here and we'll be open for discussions.
Yep. Yeah, and if you don't mind, real quick, Costa, before I pull it back, there is one question that was brought up about that metal gear that you were highlighting, specifically about patterning. So the question is, the metal gear that was on the screen earlier, can QuickSurface recognize a repeating pattern and recognize that each tooth should have the same dimension? Do you mind speaking to that for really briefly? Because I know the way that I approach it. I'd be curious to see the way that you approach this. So to answer the question from my end, yes, QuickSurface can do patterning, but I'll pass it off to you, Costa.
We leave this decision at the moment to the end user. When you have this, you have the freedom to decide which one to pick. If you have ideas how we can improve this, do you want us to implement something more than this averaging and stuff? Perhaps we can implement. But the current approach is you have something, you pick the best shape here that it works for you, then I can just quickly reconstruct or reconstruct according to the standards. I'm not an expert in this case. I can just reconstruct. We just provide these mathematical shapes, and then I can just use this as a shape, and then I can just pattern it. But how you define this, probably there are a lot of standards about this. So I honestly, in these cases, would trust the standard rather than the actual scanning. What's going on. It's good for a reference, but decision is yours, because I can just make this a normal solid that will be used as a cutting tool. I can just press OK, and then we Yeah, we didn't mention, but we have the patterns like in any CAD packages, you can just use this to define what you needed. Like you see
Perfect.
on the screen.
Yep.
So I hope this answered the question, but yeah.
So just to do a brief recap of what we discussed. So with your scan to CAD workflow, the important highlights here are obviously we want to scan the object, then we're going to bring that into QuickSurface. But from there, as Costa mentions, the most important aspect is alignment. Once you have a part aligned correctly, things become a lot easier. So from there, you're going to determine your design intent. You're going to model that part and then analyze it. And that model and analyzing can kind of be a little bit of a loop until you get the part correct for your application, which again, that's where the parametric side of QuickSurface makes it extremely easy because we can go back and quickly change things on the fly. After that, you're going to export out your CAD model. So a couple things for housekeeping. So we are going to be sending out an email to all the attendees after this webinar. That'll get you a free 30-day trial for QuickSurface. As well, we're going to be sending out an email where if you want a 30-minute live session with myself where we can walk through your parts, we'll send out a Calendly link so you can book a 30-minute time slot, as well as we'll send you a link where you can upload your actual STL data. So if you have an STL mesh that you want to see how I would approach or reverse engineering that particular part, feel free to sign up for one of these time slots and book that demonstration. So with that, we'll go ahead and jump here into the Q&A. So I've got a few questions to go through here. So question number one for you, Kos. It looks like there's a customer that purchased QuickSurface Lite and does not have chamfer, fillet, or analysis, so the 3D comparison capacities. Do you want to speak to that a little bit?
Yes. So we created QuickSurface Pro, and I hope that you like it with a lot of amazing tools that we have. And due to the push of the other requirements that some people have their own solutions, all they wanted to do is just to prepare the scan data and extract a couple of features and finish off in their favorite packages. That's why we created QuickSurface Lite. QuickSurface Lite is not a complete package. It's just you can assume this as a QuickSurface Basics, which fills you the gap to people who already are in favor in other solutions without our tools. They already have, I don't know, any other package, and they say, I have this already. I don't need this. I don't need this. All I need is just to align the mesh. All I need is just to create a sketch. Everything else I can do in my package. So that's why we created. If you look at the prices, it's times way cheaper than this. So that's why many people just believe that Lite is as powerful as QuickSurface. No, QuickSurface Lite is just a preparation for you to start the reverse engineering. How you want to continue your journey is your choice. If you want to go through the QuickSurface Pro, you're welcome to do this. But if you find your own approach with your other packages, that's the flexible world that we have.
Perfect. Thanks for that, Kosta. So another question about educational packages. Yes, to the person that asked that question, we'll reach out to you. We do have educational packages for QuickSurface, so we can have our team get in touch with you and provide some pricing for you.
Yeah, there is a next
Go ahead,
question.
Kosta.
Yeah, I'm not going to
Sure.
read it. It's about our competitor. Yes, we have a famous competitor in the world. People may know it. I don't want to mention. First of all, I'd like to say we never compete. It's a great product. If you can work with it, feel free to use it. I would like to highlight some of our advantages that might be interesting, but this is only my personal opinion, and in any way, I don't want to disrespect the other product. First of all, we are dynamic. We are creating products and features every year. You may notice this. Also, we have tools that are really different from what you've been using. we have this, our automatic surfacing is completely different. Our hybrid approach to do this is completely different. The deviation, real-time deviation analyzer is also completely different. But more that I would like to add to this is that we as a quick surface, we don't only offer the software on its own. We provide the support, we provide the agility, we provide the groups, we provide the flexibility to jump in and resolve the customer's problem. We create the content every day. Also, the learning curve from our software to the, to how to use this product is much, much faster and so on. So there, around the product, Paul can confirm this, we build up a whole new way of thinking of what the reverse engineering is. That's the
Yeah,
huge difference.
absolutely. I mean, one of the things I kind of pride Quick Surface on is, just over the years, you as your team have been extremely receptive to just kind of sandboxing different ideas of how we can approach reverse engineering, right? And me and you have been able to kind of bounce ideas back and forth off of each other and change this to be not just the standard way that things have been done in the past, but processes that make more sense for us, right? It makes sense more from a manufacturing standpoint for a lot of people. Yeah. Anything else you wanted to add to that, Costa?
No, no, that's, I
Okay.
hope this answered the question, but if you have
Yeah.
any other questions, anytime you can contact Paul and get
Absolutely.
answers very quickly. Uh,
Absolutely. So let's see, Pauline, are there any questions that were missing? I think that's everything on the Q and
Yeah,
A.
there's one in chat. I don't know if the person can see it, but there's a question. Would it be possible to reduce the number of final multiple surfaces generated for the body by the auto freeform to only a few main surfaces we could select? If you could
okay.
address that, yeah.
Yeah, I will answer this live. So again, the perception is the dream. Okay, auto surfacing created by, in reality, I just need a perfect model which is with a nice surface with a G2 continuity, G3 continuity, with a perfect edges.
Right.
No, that's a different technology. It's a totally different approach. If you want to achieve what you're asking for a single surface on top that transition to another main surface, quick surface allows you to do this, but it's with the fit surface command, which is extremely powerful. But then you enter into the traditional cut modeling where you need to intersect, blend surfaces. We also support a lot of this, and we'll be happy to show this in our future session. Or probably the best is if you just contact Go Measure 3D, and they'll be really happy to show the biggest difference between these two different technologies.
Exactly. Perfect. No, thanks for that answer, Costa. So yeah, I believe that's all the questions for now. Now, one
Oh,
thing,
Paul, sorry,
yeah,
Paul, there is another question in the
okay,
Q&A.
Yeah.
Said, for someone who,
oh,
with no prior experience in 3D scanning, what is the usual workflow for combining multiple scans into a single complete 3D model? And what
sure.
are the main challenges beginners should be aware of?
That's a great question. So with your general workflow on the 3D scanning side can vary fairly drastically depending upon the type of 3D scanner that you purchase. But traditionally, you are going to have to scan that object either with or without reference markers. So for us at Go Measure, we sell two different technologies: structured light versus your traditional handheld laser. So you'll either use markers or not to be able to track the scanner in 3D space. Once that scan data has been collected, as you mentioned, you may have to scan multiple areas around a part. Once you're satisfied with having those multiple areas, then traditionally in the 3D scanning software that you're using, you will combine that mesh data together into one solid polygonal mesh. So you're going to either fuse it, or different softwares have different names for it, but we'll combine all of the individual data points or individual frames of that scan file into one STL mesh, and then you can take that over to QuickSurface. So you also mentioned challenges that beginners should be aware of. If you're using lower cost 3D scanners, be mindful that you'll have some issues with tracking and issues with various colored data or colored objects, right? So generally speaking, what I recommend for a beginner is if you, let's say you purchase a low cost 3D scanner and you're having trouble scanning, you're having trouble tracking, quite often it's either a lack of reference points if you need reference points, or it's an issue with the actual color of the object, is where I would recommend you use a product like ASUB, a 3D developer spray. That's generally what we call the easy button for anybody new to 3D scan. So you can spray this spray across the part. It'll sublimate after a few hours or up to a day, depending upon which ASUB product you use. But that's what I would consider to be the easy button. It's relatively inexpensive considering the industry at somewhere around $30 a can or so. So hopefully that helps to answer your question there on 3D scanning. If you have any other questions, feel free to reach out to us directly. Then we've got another question that popped up. Yeah, everybody's putting some late questions in, which is good. Educational versions. Yes, yeah. So we do sell educational packages. So I'll reach out to you as well directly, and we can discuss that further after the webinar here. And can you import solids into the software? Yes, you can import solids into the software. Costa, do you want to just highlight that real briefly?
Well, you can import, just go and file import as it's a feature tree. You can import step images, solid file. You can put it as an entity inside and use it as a reference. You can combine, recreate if you want. Just one thing I want to make it clear. QuickSurface is designed to recreate a single part. It's not an assembly package. It's not like that you can create assemblies. It's not designed to support assemblies, let me put it this way. So let's have a realistic expectations. Why you
but
need imports, yeah.
To that point, though, that I have done some fairly complex parts, complex like chassis for like automotive chassis, where I've actually used QuickSurface to like build a part, export it out, and then hold onto that part for multiple, like if it's a redundant part around the object. Because in the software you can move pieces around, but you can also do mirrors, and you can make some pretty complex parts with it. But to your point, there's not a the assembly side isn't what QuickSurface is built on, but you can do some pretty impressive stuff with it.
Yeah. Right. You discover more applications. I just mean say that we don't have these mates and constraints in 3D. That's what I mean. Otherwise, you can have a lot of really, it can build a lot of interesting projects, I can say.
For sure. Yep. And I know we don't want to keep everybody past the hour, but just as one last thing, we are going to have a questionnaire that'll pop up at the end of this webinar once we close it off. So if you have any interesting topics that you want us to discuss in the future, like for instance, diving deeper into hybrid modeling, that can be a really complex topic, or anything else, whether it's just introduction to 3D scanners, feel free to answer that questionnaire at the end. It'll definitely help us out with discovering what you want us to present in the future. So Costa, thank you very much for joining us in on this webinar.
Maybe you can share all the credits at the end, your last slide.
Yes. Yeah. I should have done that. There we go.
Yeah.
So we got our contact form. Yep. Perfect. All right. Yeah. Thank you again, Costa. We really appreciate having you on, and thank you for your time. And then also everybody else, thank you very much for joining in on the webinar. And yeah, if you have any questions in the meantime, feel free to contact us at Go Measure 3D, and we'll be more than happy to answer those questions for you. So thank you all very much.